So today I'm going to quickly show you Ohm's law and how to use it to work out what strength resistor you need in your circuits. We're going to be using an LED circuit as an example, and let's first state Ohm's law. So it just tells us that voltage is equal to current multiplied by resistance. V equals I times R. V is voltage, I is current, and R is resistance. So to work out what the resistance should be given the voltage and the current, we just jimmy the equation around and we get that the resistance is equal to the voltage over or divided by the current. Okay, so let's have a look at a data sheet for a specific LED to look at an example. We need to look at two things on this data sheet. Firstly, the forward current, which in this case is a maximum of 20 milliamps. So we need to know that the current is 20 milliamps if we're going to be plugging into our equations. And then further down we look at the forward voltage, which you can see the test condition is under 20 milliamps, which is what we want, and the minimum forward voltage is 1.8 and the maximum is 2.2. So for our calculations we're going to plug in 2 volts. It lies right in between the min and the max. Okay, so we're going to plug in 2 volts into our calculation. So now that forward voltage is also what we consider to be like the drop voltage of the LED. So we're going to draw up a circuit of an LED, and you can kind of think of this like a game. At the top you've got the power source, and at the bottom, all the way at the bottom, you've got ground. And basically what you start off with at the top, your power, is you start up with 5 volts in our case, because that's what Arduino gives you. And by the time you get to ground, you want to have dropped all 5 of those volts and reach 0. And in between power and ground we have a resistor and an LED. Now we already know that the LED drops about 2 volts. That's what we saw in the data sheet. So that tells us that there are 3 volts, quote unquote, left over, and we need the resistor to drop those, because it's the 5 from power minus the 2 that are dropped by the LED. So the resistor needs to drop 3 as well, and we've got 20 milliamp current running throughout. Okay, so now we know that resistance equals voltage over current, and we also know that voltage is equal to the voltage from the source, that's Vs, minus the voltage from the LED. So that's a calculation we did, the 5 minus 2 calculation that gave us 3. So when we're dealing with this sort of thing, that's what the voltage actually equals. It's the voltage from the source minus the voltage dropped from the LED. That's how we're working out the voltage for the resistor. Okay, so let's plug that into our equation. Our equation now becomes that the resistance equals voltage from the source minus voltage from the LED over current, which is 5 volts minus 2 volts over 20 milliamps. Okay, but we need to convert those milliamps to amps. It needs to be voltage over amps. So 20 milliamps divided by 1000 gives you 0.02 amps. 3 volts divided by 0.02 amps gives you 150 ohms. That omega sign is the symbol for ohms. Okay, there's also an online calculator that helps you do this that I found. You can see the URL at the top there that I've highlighted. There's an explanation here of how some of this stuff works, which you can read through. I'm trying to make this tutorial very quick, so I won't read through it now. But basically you plug these values in there. So again, the voltage from the source with an Arduino is 5 volts. The voltage drop from this LED in our case was 2 volts. The current through the LED was 20, and I must change the units from amps to milliamps, or I could have put in 0.02 amps if I wanted to. You click calculate and it gives you the same result, 150 ohms. Simple as that. It also gives you the LED power, but we're not worried about that now. So thanks very much for watching this. I hope you found it useful. I hope you learned something. If you want to learn more about things like this, please subscribe to my channel.